Good afternoon, everyone. Today I'll be going through the Diamond High H2 Math Prelim 2022, Paper 2, questions 1 to 5. So basically pure math. I'm keeping the stats for closer to the A-Level Paper 2 date. And if I have time later tonight, I will record the solutions for Hwa Chong, Paper 1, questions 1 to 7. If I don't have time for that, I'll do that another day. But for now, first question is a sketch hyperbola. Now, I think a lot of schools are predicting that hyperbola will come out or conic sections will come out because it hasn't come out for past year A-level papers until now. If you write the equation of the hyperbola in the standard form, you get this. So this might help us a bit in the sketch. Okay, so this is x and this is y. This is the origin. Then the center will be 0 and -1. And the vertex of your hyperbola is here. Okay. So let's draw the asymptote. What is the gradient of the asymptote? If you consider y over x, you will get 2 over 3 as the limit. So you will get an asymptote that looks something like this, and then extend to the other side. Same with this one. Okay, let's draw the hyperbola. This is a distance of 3, and the other side of the hyperbola. Okay, y equals to rather 4x squared minus 9y plus 1 squared minus 36 equals to 0. Okay, so this is the y equals to 2/3 of x minus 1, and the bottom one is y equals to -2/3 of x minus 1. Okay, find the volume generated when the region bounded by the curve and the line x equals -√45/2 is rotated through 2 pi radians about the y-axis. So you will actually notice that this will be exactly this point here. So let me label this intercept actually. -3√5/2 and positive 3√5/2. We are considering this line here. Okay, so what we're considering is this region rotated by 2 pi radians about the y-axis. Okay, and the radius of this is of course √45/2. So we will consider a cylinder minus the volume of the generated by the curve, right? So part 1b, required volume will be the volume of the cylinder, so pi, then the radius is √45/2 squared. The height will be, by symmetry, this is -1, this is 0, so this is actually -2. So this is going to be 2 minus, then we're going to have an integral, pi, integrate from -2 to 0, express, make x squared the subject, you'll get 36, you'll get like, how do I say it? You get pi over 4 let me just write the whole thing first. Quarter of 9y plus 1 square plus 36. Okay, dy. Okay, then we will evaluate this. Now this is 45 pi over 2. Now we factor out the 9 quarter pi, so 9 pi over 4, integrate negative 2, 0. Y plus 1 square, then you will get 4 here. So I'll expand this to y squared plus 2y plus 5. Of course, you can integrate that directly if you want. You get 45 pi over 2 minus 9 pi over 4 y cubed over 3 plus y squared plus 5y, evaluated from negative 2 to 0. And of course, if you put 0, you just get 0. So we just need to consider negative 2. 45 pi over 2 plus 9 pi over 4. And then we will get negative 8 over 3 plus 4 minus 10. And this is negative 6. So negative 32 over 3, which makes this 3 pi negative 32, negative 24. Or rather, no. Oh, sorry, this is negative 26. Okay, I was thinking of 8, not 6. So this is negative 26 over 3. And this will simplify to negative 39 over 2. So therefore, you just get 3 pi as the exact volume. Okay, that's good. Question 2, complex numbers. There's actually an error in the question. I'll get to that later. Find w cubed in this form. Okay, so 2a. So we have w equals to 2 minus 3i. Now, of course, the question says don't use a calculator, but you can use a calculator to check your answer. W cubed, you use the binomial theorem, so you get 2 cubed plus 3 2 squared minus 3i plus 3 2 minus 3i squared, and then plus minus 3i cubed. Okay, which is 8 minus 36i. Then when you square this, you get negative 9. So you get minus 54. And then cube this, you get negative 20. No, wait. Oh, wait, no, you get 27i positive. Okay. So you should get negative 46 minus 9i. Okay, you can use your calculator to check this. Okay. W is a root of the equation z cubed minus 5z squared plus az plus b equals to 0, where a and b are real. The equation also has a real root alpha. Okay. So a and b are real numbers, so you can use conjugate roots, right? Since a and b are real numbers, conjugate of w, so w conjugate equals to 2 plus 3i is also a root. So one can write z minus 2 plus 3i and z minus 2 minus 3i, and this will be a quadratic factor of the cubic. So this is z squared minus 2 minus 3i times 2 plus 3i. So they are conjugates, so you get the square the modulus, and the real part will be negative 4, so you get z squared minus 4z plus 13. Okay, so therefore we write z cubed minus, we can write z cubed minus 5z squared plus az plus b equals to z squared minus 4z plus 13, and you will notice that the linear factor, the coefficient of z must be 1, and for the constant term we need plus 13 over plus b over 13. Okay. So one can make the comparison between, I think, the coefficients of z squared. Yeah. Compare coefficient of z squared. So b over 13 minus 4 is negative 5. So therefore b is equals to, b is equals to negative 13. And from here one can also find the value of a. So compare coefficient of, I think comparing coefficient of z might help us for this. If we do that, minus 4 over 13 plus 13, or rather no, sorry, minus 4 times is negative 1, right? So it will be positive 4. 4 plus 13 equals a. So therefore a equals to 17. Okay. So take note, a is 17, b is negative 13. You can obtain this in any way. Find a cubic polynomial that has roots iw conjugate, and I alpha in the following form. Now the problem here is that these are not conjugate roots. I alpha does not have a conjugate root, so it's impossible for p, q, and r to all be real numbers. Okay, so we don't actually need to expand by hand. We can actually observe that we can make the replacement of z by z over I, because if you put iw, then the I will cancel out so that you get w as a root of the z cube something. So we'll get z over I cube minus 5z over I squared plus a, or rather plus 17 z over I minus 1. Okay, or minus 13, sorry. Okay, and dividing by I is the same as multiplying by negative I, so the result here will be iz cubed minus, okay, so this is negative 1, so plus 5z squared minus 17i minus 13. Okay, so let me decide this by, let's set this to be 0, and I'll set this to be 0, and I'll divide throughout by I, so that I get z cubed minus 5iz squared minus 17z plus 13i equals to 0. So this will be the cubic equation that you're looking for. The problem is that P, Q, and R are obviously not real here. P and R in fact are imaginary. I think there's an error in the question, but we'll leave it at that as the answer. Question 3. Okay, so for this we have a rational function. So we have y equals to 4 times x minus 2 squared divided by x minus 4, which I shall expand a bit. So this is 4x squared minus 16x plus 16 divided by x minus 4. And if I simplify this, I'll get this is actually 4x times x minus 4, so 4x plus 16 over x minus 4. Okay, so immediately the vertical asymptote is actually, or the oblique asymptote is just 4x. Okay. So we're going to center the graph about x equals to 4, but we're going to use a 2:1 scale because quite big to draw 4x on one graph. So let's see what that looks like. Okay, the vertical asymptote will be x equals to 4, and it should probably occur somewhere around here. Now, if you use GC, you'll actually find that the curve does have stationary points. So I should probably draw the thing a bit lower. Okay. Okay, cool. So there's a turning point and it's exactly at 2, 0. So we'll draw it here, diverging from the oblique asymptote, and the vertical intercept will actually be -4, which is we're using a 2:1 scale, so that will be here as well. No, I didn't mean to draw a straight line. Never mind, let's draw it a bit higher. And then turn down and then come back down to the asymptote here. A bit difficult. Okay, so this is the asymptote x equals to 4. This is the x-axis, this is the y-axis, the origin. This is the y equals to 4x asymptote. We're going to draw the other part of the curve. This, by the way, is 2 and 0. And the other part of the curve will look something like that, and it will go back up. Okay, so this is the other part of the curve, which this is the curve y equals to 4x minus 2 squared divided by x minus 4. The turning point here is 6 and 32. Yeah. Okay. equations of the asymptotes, the coordinates of the point of intersection of the asymptotes, we need to state it as the question said so. So this will be 4 and 16. Okay. Deduce the range of values of a such that this equation has a negative real root. So x minus 4 plus, you will see that this is actually y minus 16. So we're actually going to draw a circle about this point. There's a negative real root. Well, for this to be the case, we need the radius, we need the a is, we need a to be bigger than like the square of the radius of the circle. So draw circle x minus 4 square plus y minus 16 square equals to a. So a is greater than the square of the radius, which is 4 minus 2 square plus 16 square, okay, which is just 260. So yeah, that's it. A is greater than 260. Then the equation should have a negative real root. Suppose the variable point P on C, I should probably label this. Suppose the variable point P on C, it represents the complex number z equals to x plus iy, referring to the point of intersection between the asymptotes of C, find a range of values of argument z minus 4 minus 16i. Okay. So this is a very interesting, because this is like a further maths kind of complex loci question, which used to be in H2 maths, but it's not anymore. So let's have a look. If I pick, for example, this point, they're asking what is the argument of this minus that. So essentially, if you notice, right, the argument will be the angle between this point and that line. Okay. So the range of values will actually be the argument has to be more than the tangent inverse of 4, right? But it has to be less than pi over 2, because pi over 2 radians is where the vertical asymptote is. But also, p could also be on the other side. The problem here is that the principal range of the argument is not defined. So I'm going to go with the negative pi to pi definition. And the answer for this case will be the argument of this number will be, if we go in the other direction, the argument will be greater than negative tangent inverse of 4, but it will be less than it will be less than negative pi over 2. So therefore negative pi over 2 less than tangent inverse, or rather argument z minus 4 minus 16i less than negative tangent inverse of 4, or tangent inverse 4 is less than the argument is less than pi over 2. Yeah, that's actually the answer. Not sure what working they expect though, so maybe you can go and think about it. But this should be the answer. Okay, question 4 and 5. Question 4 is a vectors. Relative to an origin O. So take note of what's happening in this question. The position vector of P, Q, and R, I2j minus tk and tk respectively. So let's say that I call this, let's say I draw the diagram. Let's say this is Q and this is P and this is R. The points A and B divide both line segments and QR, PQ and QR respectively in the same ratio of mu to 1 minus mu. So that looks something like this. Oh no, sorry. Be careful. PQ, that means that this part is mu, this part is 1 minus mu. And this part, QR, this part is mu, and this is 1 minus mu. Be very careful with the wording. So let me just make that a bit neater. Let's say I cut it here, and I'll cut it also here. So this is mu, and this is 1 minus mu, and this is mu, and this is 1 minus mu. Okay, join the points together so that I get here, this is A, and this is B. So we can find OA and OB in terms of mu. By using the ratio theorem. So if you use ratio theorem, OA is actually 1 minus mu OP plus mu OQ, and OB is by ratio theorem will be mu, or how about 1 minus mu OQ plus OR. Okay, then AB is OB minus OA, so that you get one minus 2 mu OQ, then the OP comes in, so plus mu minus 1 OP plus OR. Oh, this is mu, sorry. Mu OR. Okay, simplify this a bit. So we need to look at I. The only I component comes from OP. So the I component is mu minus 1. The J component depends on both Q and R. So, no, it only depends on Q, sorry. So that is just 1 minus 2 mu. Or rather 2 minus 4 mu, I think. Because it's 2 times. And finally, the K component is dependent on Q and R. So you get 2 mu minus 1 T and mu T. So you basically get 3 mu T minus T. Okay. Yeah, it's a bit messy, but that's it. Determine whether O, A, and B are collinear. This should be a no-brainer, but they are not, because they cannot be expressed as scalar multiples. I can try to write it explicitly. So for B, OA is 1 minus mu OP means it is 1 minus mu up here, and mu OQ just means that it's 2 mu and minus mu T here. Okay? And clearly this is not equal to alpha of AB. Alpha is a real number, therefore not collinear. Okay. My mouse is being recognized as a pen for some reason. Okay. Find the values of mu such the length of projection on AB onto 340 is 1 over 5. So length of projection is mod A dot d cap. So mod 340, take note that mod 340 is the square root of 3 square plus 4 square, which is 5 exactly. So therefore we have to consider length of projection is A dot d cap, which is A dot d divided by mod d. So this is 1 over 5 mod. So we dot the vector mu minus 1, 2 minus 4 mu, and 3 mu t minus t. Dot this with 340. And we figure out what this is. So this is 3 mu So you see the 0 part, actually the t doesn't really matter. So if I put 3, so I get 3 mu and I get minus 13 mu, so I get minus 13 mu, yeah, and minus 3 and 8, so I get 5 minus 13 mu. So this equals to 1 over 5. So therefore 5 minus 13 mu equals to plus minus 1, and you can go and find the two values of mu from there. Okay. So mu equals to, if it's equals to 1, then mu is 4 over 13. If it's minus 1, then it will be 6 over 13. Given the angle AOB is right angle, find the set of possible values of t. So if AOB is a right angle, then the dot product, scalar product of OA and OB will be 0, right? Because this implies that OA, OB are perpendicular vectors. So for this, OA equals to, I think, 1 minus mu, 2 mu, and minus mu t. What is OB? Let me just check. Oops. Okay. OB is 1 minus mu OQ. So that's 1 minus mu. There's no I component, so it should be 0. That's written here. It's 0, 2 minus 2 mu and 2 mu t minus t. Okay? Because the j component is only determined by OQ, so it's 1 minus mu times OQ, and the k component is 1 minus mu times t, or rather mu minus 1 times t plus mu t itself. So you get the 2 mu t minus t. So we find OA dot OB. So you get 2 mu, 2 minus 2 mu and then minus mu t, 2 mu t minus t, and this gives us 4 mu minus 4 mu square minus 2, wow, messy, 2 mu square t square plus mu t square. And because we want to solve for t, factor out the t mu, factor the t squares out, I think. Or no, we'll factor out the mu square and mu. Let's factor out the mu square. Let's factor out the mu's. So we get negative 2t square minus 4 mu square minus plus mu 4 plus t square. Set this to be 0. Now we want to arrange them in this way because we want to solve for mu. Because for this to be possible, we need to have this equation to have real roots. So we make the quadratic equation in terms of mu, then we determine the conditions on t. We can actually divide throughout by mu since mu is clearly not 0. We add 2t squared minus 4 on both sides, so t squared plus 4 equals 2t squared plus 4. So therefore we get oh no, we need the discriminant, sorry. How do I explain this? We want this to have real solutions, so discriminant this is b squared minus 4ac, which is just 4 plus t oh wait, not discriminant. What I just did just now, yes. 4 plus t squared equals to 2t squared plus 4 times mu. Okay, so therefore 2t squared plus 4. Now 0 less than mu less than 1, so this here is going to be greater than t squared plus 4. Because once you get rid of the mu, divide by mu, you're making this bigger, so you eventually get to t squared greater than 0, so therefore t is just not equal to 0. So in other words, the set of values is t is a real number except for 0. Quite a tricky question. Question 5. Okay, integration. So we have to integrate sine x times 1 minus sine x. This is the integral of sine x minus sine square x. Sine square can be expressed as 1 minus cosine 2x divided by 2. And this is negative cosine x. And then you integrate the negative half x plus, now this becomes a plus cosine 2x over 2. So when you integrate, you divide by 2, you get a quarter sine 2x plus the d, where the d is the arbitrary constant. We have parametric equations. I think this is the cycloid curve. Let me just get my GC. Oops. Oh, this is not the cycloid curve, but it is a bit related. And it's only 0 to pi over 2. Okay. So 5b, for this you will actually have found, if you sketch on the GC, that the curve lies completely in the first quadrant. So this is y and this is x, and this is the origin. And it seems that the curve doesn't get too far away. So this seems to be a stationary point. The curve doesn't get too far away, and then it turns back. And it becomes like a bell kind of shape. And the intercept is at 1. So what's the gradient at that point? Is there a gradient? Oh, the gradient is just infinite. Almost. So it kind of intersects at like a parallel to the y-axis kind of thing. A bit hard to draw. Okay, there you go. This is 1 points intersection with the axis, so this is 0, 1, and this is the origin, and the curve is a bit, yeah, like that. Okay, the axis is a bit far. Let me bring that nearer. It's not that far out. Okay, so there's the x-axis. Okay, so that's the curve. A point lies on C where the tangent is parallel to L. The line L has the equation y equals to 2x. Okay, so of course you can just draw that normally. And in case you don't know how to draw that on your GC, with parametric mode, just put t and 2t as your parametric equations. And it looks something like that. So this is y equals to 2x. So this is C. Okay. The tangent at P is parallel to L. Find the coordinates of P. So we're going to find the point on the curve where dy dx is 2 basically. So you don't really need to sketch the line on the curve now that I think about it, but never mind. Phi C, we have x equals to theta, 1 minus sine theta, and y equals to 1 minus cosine theta. So we find dx d theta. This is 1 minus theta sine theta, differentiate, you get sine theta minus theta cosine theta. Yeah. And dy d theta is very simple, it's just sine theta. So therefore dy dx is sine theta, 1 minus sine theta minus theta cosine theta. So let dy dx equals to 2. Now, of course, this is not something that we can really solve easily, so we will use our GC to help us. Using GC, we have theta equals to 0.42230. Oops. But we're not done yet, because we need to sub back in to find x and y. So I get the coordinates to be 0.249 and 0.0879. Okay, yeah, QSF. Okay, (5D), find the exact area of the region. So we are going to integrate x dy. So area equals to the integral, but we need to replace dy with something to do with d theta, right? So you replace it with dy d theta d theta. So the area will be 0 to, actually let me write down x dy, this 0, 1 x dy. Change the limits of integration. X is 1 minus cosine theta, or rather, no, it's theta 1 minus sine theta, sorry. So theta 1 minus sine theta, and then dy d theta is just sine theta. D theta, and this is going from, you change the limits, so the bottom limit is 0 and the top limit should be pi over 2. Okay, but how do you integrate this? Now, we actually found the integral of sine x times 1 minus sine x earlier. So what we're going to do is actually we're going to use integration by parts. So I let this be my dv dx basically, because I know how to integrate this. So I get negative theta cosine theta minus theta square over 2 plus theta over 4 sine 2 theta. And then I need to subtract the integral of, I take the integral of the integral of this, which is negative cosine theta minus half theta plus sine 2 theta over 4 d theta, and I take this as limit 0 to pi over 2. A bit messy. Okay, so let's see what happens. I put in pi over 2 here, this 0 gone, pi square over 8, this pi over thing is also gone, so this is just negative pi square over 8, I think. Okay, and now we're going to integrate this 0 to pi over 2, and we're going to flip the signs around, so this is cosine theta plus theta over 2 minus sine 2 theta over 4d theta. Okay, so this is negative pi square over 8 plus sine theta plus theta square over 4 plus cosine 2 theta over 8. And this goes from 0 to pi over 2. So this is negative pi square over 8 minus, plus 1 plus pi square over 16 minus 1 over 8, 0, 0, and then minus another 1 over 8. Then you get 3/4 minus pi square over 16. So that will be the area. A point Q lies on C such that OQ makes an angle of pi over 6 radians with L. Find the value of the parameter theta for Q. Okay. This is another tricky one. If we go back to our graph, we want it to make an angle of pi over 6 radians. So pi over 6 is 30 degrees. You can't really see it that well because I drew it a little bit off, but 2 is greater than root 3, so therefore the tangent inverse of 2 is greater than pi over 3. So we need the angle to be clockwise. So let angle between OQ and L be phi. Okay, so we're going to let phi, so we see that phi is actually tangent inverse of 2 minus pi over 6. Okay, or no, actually it's a tangent phi, sorry. Tangent phi equals to tangent of this. Yeah. So one obtains, now tangent phi is also the same as rise over run. So we get y over x, which is 1 minus cosine theta divided by theta times 1 minus sine theta. Okay, and then what is tangent of tangent inverse 2 minus pi over 6? It turns out to be 0.66025 to phi SF. From here, once again, you need to use your GC to find the answer to this. So now you're looking for a solution in the interval 0 to pi over 2, of course. So using GC, only value of theta for 0 to pi over 2, right? Is 0.596. Yeah, so this will be the corresponding parameter. Yeah. Okay, so that will be all for Diamond High, paper 1 the pure math section, it's quite tricky, I feel. I usually think that paper 2, the pure math, is easier than paper 1, but Daman High has set quite a bit of standard here. So kudos to them. I looked through the stats. The stats is a bit more manageable. So when I get to the stats questions later on, hopefully I should not struggle that much. And hopefully everything is okay with you guys as well. As I said, if I have time later tonight, I will record the Hwa Chong paper 1, questions 1 through 7. If I don't have time tonight, I'll probably find one of these days. All the best to those taking the A levels coming up on 8 November for H2 Math paper 1 and 11 November for paper 2. And I'll see you all next time.